circles. In this video, we see why math is art and how the tangent function does some really weird things. Okay, so here I graphed an equation and we have circles, just a bunch of circles. And as we can see, there's all the circles have the same center at the origin and they have radii increasing, starting slightly below 1, then slightly below 2, then slightly above 2, maybe about 2 2/3, then like 3 1/7 maybe. And we know that like the distance between the two circles, for example, from here to here, it's getting smaller on every circle. Okay, so what equation did I use and how is it possible to make something like this that's infinitely large with infinitely many circles, that is infinitely complex? First of all, the equation that I used was actually tan of x squared plus y squared is equal to 1. But how does that form these circles? So we have the equation, tan of x squared plus y squared is 1. But how does this equation produce a seamlessly complex infinite circles? Let's take a closer look. Let's define z to be x squared plus y squared. So then tan of z is equal to 1. So then, since I did this in radians, we know that z is pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4, and so on. Because every 2 pi, it's the same value of tan of z. So then, x minus 0 squared plus y minus 0 squared is equal to one of those values, because we know that x squared plus y squared must equal to z, which is one of these values. So then, that's a circle with center 0, 0, with radius, the square root of this, the square root of pi over 4, that's the first circle. The second circle has a radius of square root of 5 pi over 4, and so on. So that's how tan of x squared plus y squared is equal to 1 turns into infinite circles of distinct radii. So that was interesting, and see you next time. Make sure to like, subscribe, and share if you found this video intriguing, interesting, or useful. Bye.